Hello, guys. Welcome to Ramta Solutions. Welcome to your Electrostatics exam prep of grade 11 and grade 12 physical sciences. Today, the question paper that we are looking at is the Eastern Cape's grade 11, November 2022. Now, before we get into the questions, let's remind you of some few instructions. Remember, guys, when you are when you are writing examinations, it's important that you read all the instructions. However, I'm not going to read all of them. I'm going to highlight just a few. Instruction number 8 says, show all formulas and substitutions in all calculations. Instruction number 9, round off your final numerical answers to a minimum of 2 decimal places. So a further tip that I can give you here is this for instruction number 9. In the middle of your calculations, if you happen to get decimals, maybe work with about 4 or 5 decimal places. Of course, you don't want to work with 100 decimal places, right? So work with the minimum of 4 or 5 decimal places and only your final answer rounded off to 2 decimal places. Then instruction number 10, give brief motivations, discussions, etc. where required. Remember, this is physical sciences. There is no question, there's no essay question on physical sciences. And instruction number 11, you are advised to use the attached data sheets. In case you forget your formulas or your constants, you can always refer to your data sheets so you can get your formulas. Remember, it is not all formulas that are given, but major formulas are given. Instruction number 12 is an important one, which I think as you practice the concepts, guys, wanting to know what is what, please also work on improving your handwriting. Okay. All right. So this is a grade 11 past paper. So our electrostatics question could probably be question 6. But let's see. 3, 4, no, 5, no, 6. Yes, it is. So yes, it is question 6. So let's go. So it says two small spheres, 6.1 by the way, two small spheres, each of mass 5 kilograms, 5 grams in that, are arranged on the diagram below. Q1 with a charge of positive 4.5 times 10 to the negative 9 coulombs is suspended from a light inextensible string secured to a support. Q2 with a charge of negative 2.5 times 10 to the negative 9 coulombs is placed vertically below Q1 so that both charges are in a straight line. Okay. Both spheres come to equilibrium. Did you hear this? Both spheres come to equilibrium when Q2 is 3 centimeters from Q1. Ignore the effects of air friction. All right. Question 6.1.1. Calculate the number of electrons that were removed from Q1 to give it a charge of positive 4.5 times 10 to the negative 9 coulombs. Assume that the sphere was neutral before being charged. So the formula that you are using, it is given, guys, it is given in your formula sheet. It is 6.1.1. It is number of electrons is equal to charge of the sphere over charge of an electron. Let's go check it out. Here is it. Do you see it? Here is it. And the charge of an electron is a constant. It's also given, which is negative 1.6 times 10 to the negative 19 coulombs. Okay. So remember, before I proceed, remember, it's important that we spend 1 mark. For 1 mark, we spend a minute. So in this question, we need to spend about 24 minutes on this question at most. Okay. All right. Let's answer the questions now. So the charge of the sphere was 4.5 times 10 to the negative 9 coulombs. And charge of an electron is 1,6 times 10 to the negative 19 times 10 to the negative 19 coulombs. Now, what is our answer? Let's see. So our answer here is, we have correct to two decimal places. We have 2.81 times 10 to the positive 10 electrons. So these are the electrons. Okay. So these are the electrons that were removed. Remember, they were removed because this sphere Q1, right, is positively charged. Okay. Perfect. Now let's go. 6.1.2. Draw a labeled free body diagram showing all the forces acting on Q1. So this is Q1 free body diagram. Remember, it has what we call tension. As you can see, the tension, which is that force right from the string. It is the tension, right? And then it has electrostatic force. Because it's a force of attraction, the electrostatic force will be going downwards. So the electrostatic force, and then it has gravity as well. So here is gravity, the weight, isn't it? The weight, right? So our 3 marks are like this. So we are good. Okay. Now, 6.1.3, state Coulomb's law in words. It says, no worries, Coulomb's law in words. It says the magnitude of the electrostatic force exerted 1 point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the charges. But let's write it down. Magnitude of the electro. Ooh, what did I do now? Oops, I went so far. Okay, now. Thank you. So magnitude of the electrostatic, magnitude of the electrostatic force between 2 point charges, let me write that one, between 2 point charges. I think let me change it to this. Between 2 point charges is directly proportional, is directly proportional, is directly proportional to the product, is directly proportional to the product of the magnitude of the charges, of the magnitude of the charges, and inversely proportional, and inversely proportional, and inversely proportional to the square, and inversely proportional to the square of the distance between them, to the square of the distance between them, to the square of the distance between them, right? To the square of the distance between them. So we good. We have our 8 marks so far. Now, 6.1.4, calculate the magnitude of the tension in the string. 6.1.4, the magnitude of the tension in the string. Here, guys, you can use, what is this? You can basically use Newton's second law of motion, or it's totally up to you as to whether you do individual calculations. For example, remember in your free body diagram, you had electrostatic force. So with your electrostatic force, you might need to calculate electrostatic force separately or in one equation. It's totally up to you. But let's just do it in one line. So we will say F net is equal to MA. When you look at it, the tension was the one that's going up, and then we had the gravity, which is mg, and then we had the electrostatic force. Or let me do this first. And then we had the electrostatic force, which was going downwards, all right? So this tension minus Gravity is mg, that is the weight. Then electrostatic force is k, q sub 1, q sub 2, all over r squared is equal to mass times acceleration, isn't it? You can do this in one line, or you can calculate them separately, but let's do it in one line. So tension is a known. The mass of the object, if my memory serves me well, it was, let me recall, it was 5 grams. Let me check it out here. It was 5 grams. Do you see this? The mass of the sphere was 5 grams. So it'll be 5. So 5 grams, 5 divided by 1,000, it'll be 0.0005, isn't it? And gravitational acceleration is 9.8 minus electrostatic, the constant is 9 times 10 to the 9. The first charge was 4.5 times 10 to the negative 9. The second was 2.5 times 10 to the negative 9 over, what is the distance between them? 3 centimeters. So centi means 10 to the negative 2. Otherwise, you can divide by 100, which is 0.03, whichever you like, okay? All right. So let's see. Oops, don't forget equals uh, 0.005 times. It's held by the string, so acceleration is 0. Okay. Okay. So 0.005 times 9.8. What do we have? We have tension minus 0.049 minus, let's see, electrostatic force. 9 times 10 to the 9 times 4.5 times 10 to the negative 9 times 2.5 times 10 to the negative 9, right? Over 0.03 squared, isn't it? Over 0.03 squared. So we are getting 1.125 times 10 to the negative 4, isn't it? Times 10 to the negative 4 equals 0. Right. So this answer was the previous answer. What are we getting? We are getting this value here. Our tension is therefore 0.049 newtons. You can also write 0.05 newtons. I think it's okay because you're working with 2 decimal places, right? So 0.049 or 0.05, whichever you write. Okay. So this is us now. Check this out, guys. This question was basically 13 marks, and imagine we were talking and talking and talking, but we have done with it in 13 minutes. So it means we are on the right track. Okay. All right. Now 6.2. We have 11 minutes to finish 6.2. Let's see. 6.2. 2-point charges S and T are placed at 0.15 meters apart. Okay, 0.1. Ooh, hold on. 2-point charges S and T are placed at 0.15 meters apart, as shown in where is it? Okay, as shown in the diagram below. Yes, I can see it. M carries a charge of positive 45 microcoulombs, and T a charge of negative 30 microcoulombs. Point A is 0.1 meters to the right of point A is 0.1 meters to the right of point charge T on the same line as the 2-point charges. Okay, cool. 6.2.1, it says then define electric field at a point in which it is the force experienced per unit charge at the point in the field. All right, it is force. Remember, electric field at a point, it is the force experienced. Okay, it is the force experienced per unit charge at a point in the field. Per unit charge at a point in a field. Others would say it is force experienced by unit charge placed at that point, or force experienced per unit positive charge placed at that point, whichever you like. Okay, great. 6.2.2, draw the electric field pattern between the two charges. As you can see, the point S is, or rather charge S, or object S is positively charged, and then object T is negatively charged. So there is a force of attraction between the two. So we're going to do this positive, negative. So because there is a force of attraction, we're just going to do this, right? Because there's a force of attraction, we're just going to do this. So for from the positive charge, they are going outwards. So remember that they are going outwards. They're going outwards. And then for the negative charge, they are going inwards. Okay, they're going inwards. Okay, so this is it. 6.2.3. Perfect. 6.2.3. 6.2.3 says calculate the net electric field at a point A due to the two charges. So we need to know this. A is equal to KQ over R squared. All right. So something that I want you to know is this. Before I proceed, I want you to know this. You look at point S, you look at, sorry, charge S, charge T, and then point A. This one is positively charged, all right? Since it's positively charged, it means they are going towards, all right? They are going towards. So this one is negatively charged. It means they are going away from A. Okay, the charges are going away from A, but for S, they are going towards A. And remember, electric field strength is a vector. So you need to state a direction you want to be positive. I'm going to take the right as positive. Okay, I'm going to take the right as positive. So E net will then be E due to S minus E due to T. Okay, now let's go. What is this? This is 9 times 10 to the 9. What is the charge? The charge was positive 45. Okay, 45 times 10 to the negative 6 because it's micro coulomb. What is the distance? The distance here, as you can see, point S to charge S to point A, it is 0.25, isn't it? It's 0.25 meters. So square minus 9 times 10 to the 9. And what is the charge? The charge is 30 microcoulombs. So macro means 10 to the negative 6. Now, what is the distance between charge T and point A? It is 0.1 meters. So it is 0.1 square. Okay? It is 0.1 square. Now let's get our answers. Let's see. Oh, what did we get? We got 20,520,000. Okay. I want to write it as negative 2,05 times 10 to the, should be 7 times 10 to the 7. Okay. Which is 2,05 times 10 to the 7 newtons. Where? To the left, isn't it? To the left, because as you can see, this answer is negative. So if you like, you might have used, you might have written the number as is, which was negative 20. Okay, is it 20? Let me see here. It's 20,520,000, right? So then your answer is, oops, my units are wrong. So your answer is then 20,520,000 Newton per long to the left. Okay, let me fix this. My unit is wrong. We are not calculating the force. Okay, let me fix this. The units are Newton per coulomb where? To the left. Okay, so this is it, guys. This is how you attempt your electrostatic This is how you attempt your electrostatics questions in your exam. Okay. And yeah, this is it. And there's something that I want to highlight on the 6.2.2, where we were drawing the electric field pattern. Even if you have drawn the, say you have, instead of saying positive, you have said uh, positive 45 microcoulomb, and here you wrote negative 30 microcoulomb, it's still okay, right? And again, you can also draw many lines on the sphere S, or the charge S. You can draw many lines because, as you can see, it has uh, many, the charge rather is greater, right? So since the charge is greater, you can draw many lines. But what we drew is also okay, right? What we drew is also okay, right? All right, guys. So this is it. And then I hope that you now understand your electrostatics. And check this out. We were able to finish it in less than 24 minutes. So that says we are on the right track. Okay. So remember, if you would like to follow us, there's a link on this video. In the description of this video, there are links to different social media platforms. Of course, because you are probably watching on YouTube, please subscribe. And if you have enjoyed this, please like and share with your friends. So, bye bye.